Now, dear student, chapter number 5, Laws of Motion, and today we have the topic for the discussion friction, along with the subtopics are here friction as a component of force and static limiting and the kinetic friction and their graphical representation. So the picture comes in our mind regarding to the friction, that simply it is a force which act opposite to the direction of the motion. Now we have to be increase the little upgradation in the sense of the friction. Okay, so we are discussing the topic here. So about the friction, we are assuming that two bodies are in contact or their surfaces are in contact, and the one body move on the surface of the another body or tends to move on the surface of the another body. So and the relative motion between the two contact surfaces occur. So the force which comes into play, which is opposite to the direction of the motion, and it act along the contact surface. It act along the contact surface. As easily we can make the dividation of the forces by the concern of the free body diagram. So easily we can know that what will be the possible direction of the force of friction. So this force is called the force of friction we have. Now in the part of the define I am showing to you. So when the body moves or tends to move over the surface of the another body, now the movement should be there. The movement should be there or tends to move. Okay. Now the force of friction, now the force which is come into play, which act tangential to the surface of contact. Tangential, that means along the horizontal direction, along the surface where the two surfaces are in contact. So we can make the following assumptions about the friction. Now one of the basic diagram which I have taken in front of you. Now one of the box which is lying on a surface, as two surfaces are in contact, that one of the surface, that is the surface of the floor, and the box is lying on a floor, so both the surfaces are in contact. So when the friction comes in a action, as we are just applying the force on a block, okay, in a one side, so the force of friction will arise along the surface where the along the surface where the two surfaces are in contact. Okay, so probably it is opposite to the direction of the motion. Okay, as we have block is moving in the left hand side. Now suppose this one is the origin O we have, okay, of the block, and the force applied opposite to the direction, in the left hand side direction. So the force of friction will be opposite to the direction of applied force. Okay, now here we are just making the little bit resolution of the FBD concept. Here just I am taking the block is we have taken the block on the surface, so it will apply the force that is called the W on the surface, and in the reverse manner it getting the reaction that is called the R or the N, that is the normal reaction. Okay, so easily by this help we can make the resolution of the force of friction in the part of the contact force. Now we are taking the two important points about the force of friction. Friction always opposite to the motion, opposite to the direction of motion or opposite to the motion. It act when the relative motion arises. If the relative motion is there, so it will be happen. It will appear. Otherwise, it will not appear. If box is lying on a surface, doesn't mean of the friction is there. The direction opposite to the motion and parallel to the contact surface. So these are the three things we should add in the part of the friction. Now we will discuss the friction as a component of contact force. Now I have presented one of the basic diagram in front of you, and we are just assuming that when the two bodies are placed in contact, so attractive forces act between their particles at the surface of contact. As the result, the each body exert a contact force on the other. Okay, this mutual contact force are equal and opposite, obeying the Newton's third law, and the component of the contact force normal to the contact surface is called the normal reaction. So between the surfaces of the two objects there is a meaning of the force of attraction, or they are just applying the contact force on each other. So I am just making the resolution, and this resolution of the forces is called the free body diagram, that is called the FBD. So we are just assuming that the force which is applied by a block on a surface of surface, that is called the W. In result he is getting the upward reaction, that is called the normal reaction N or the R. Okay, so this is the component of the contact force we have, that is called the normal force. Either you are using the word that is called the normal force or the normal reaction. Normal reaction. So this is the simplest meaning of the N or the R we have. Okay, as we know that the force of friction which act along the contact surface parallel to the contact surface. So this is the part of representation of the friction we have. Suppose this one is a friction we have, and this one is a applied force we have. Now we are just getting the resultant of the normal reaction and the force of friction. Force of friction we have. Now we are just getting the resultant. So we are just getting the resultant between the two vectors. So this is the resultant of the contact force. So easily we can grasp the concept that the friction is always along the surface, along the parallel to and along the surface, and in the parallel or the in the tangential direction. Okay, so this is the basic concept we can resolve here in the reference of the force of friction. So whenever we are just saying saying that it act along the tangential to the surface which is in contact, so definitely we are representing it along the direction of the surface. Okay, so either it is in the tangential manner or it is parallel to the surface we have. So this is the simplest representation of the force friction as a component of contact force. Now we will discuss the next topic, that static limiting and the kinetic friction. Static limiting, kinetic friction. Now, to understand the concept of the static limiting and the kinetic friction, I assume that one of the block on the floor, and from a one side that I am applying the force on this block. So we know the force of friction which opposing to the opposing the motion, and it act opposite to the direction of the motion of the block we have. Now, as per the nature of the force, it having the tendency of the force of friction. So, whenever we are just applying the force on a block, suppose we are just applying the force on a block, that is called the 1 Newton. So, by the nature, the force of friction will act opposite to the direction of motion, and the surface is assuming, suppose, the force of friction that comes into play, and it also act the force of friction in the manner of 1 Newton. So easily we can say that the box will not move. Now we are just increasing the magnitude of the force applied 2 Newton, and suppose the surface is also acting the force of that means friction, that is in the part of the 2 Newton. Okay, still we can't say that the box is moving. Now we are just applying the force of 3 Newton. Okay, so in result the force of friction also comes in a greater, that means 3 Newton. So up to this we can say that the box is not moving. Now we are just a little bit applying the greater force, and the force applied is the 4 Newton, and here we have the limit, that is concern of the limit, that is 3 Newton. 3 Newton, because the magnitude of the force of friction can't be increased with the meaning of the force applied. Okay, so in this case what will happen, as we are just applying the magnitude of force applied, so in result it little bit increases in the part of the magnitude from the force of friction. So here we can say that we have discussed the two limits of the force of friction. One is the limit from 1 to 3 Newton, 1 Newton to 3 Newton, in which the force of friction is there, in which the force of friction is there. And the name of the force of friction which does not allow the box to move on a surface. This force of friction is called the static friction, which does not allow the box to move on a surface of another surface. Okay, so here the force of friction, and the force of friction only comes into play whenever you are applying the force. So up to 1 to 3 Newton we have the force of friction, that is called the static friction. And what is the tendency of the static friction? It does not allow the box to move. It does not allow box to move. Okay, now as we are just approaching the magnitude of force applied greater than compared to the force of friction, so in this case the box does not that slightly move or steadily move, but it just begin to slide. So in this case the force of friction which comes into play, that is called the limiting friction. Limiting friction, and somehow it is also called the force of limiting friction is equal to maximum value of the static friction. So it is another name, that maximum value of the static friction, that is called the force of limiting friction. So here the tendency of a friction, it does not produce a steady motion of a box just begun to slide, begin to slide. Now we are just increasing the magnitude of force applied. 4 Newton, after the 4 Newton we are just increasing 5 Newton, and still the magnitude of the force of friction we have the 3 Newton. Now we are just applying the force, that is called the 6 Newton. Still we have the magnitude of force, that is called the 3 Newton, and somehow we are just increasing the meaning of the 7 Newton, and still the magnitude of the force of friction, that is called the 3 Newton. So in this case we are just assuming the force of friction which exists between the surfaces, and having the name that is called the kinetic friction or sliding friction. Or sliding friction. Here box moves steadily. Here the box move steadily. Okay, so we have discussed the three types of the friction and the three range we have got. The static friction, which does not allow the box to move, as the magnitude of force applied is equal to the force of friction. Now we are just increasing the little bit higher magnitude of force applied compared to the force of friction which exists between the surface. So the box just begin to slide or just start the motion, so the force of friction comes into play, is called the limiting friction. Now the another one is that as we are just increasing the magnitude compared to the magnitude of force of friction which act between the surface, 5 Newton, 6 Newton, 7 Newton, so the magnitude of the force of friction become the lesser compared to the applied force. So in the reference of the applied force, the box is moving very steadily, okay, on a surface. So at this time the kind of force of friction comes into play, which is called the kinetic friction or the sliding friction or the dynamic friction, you can also add the word. Okay, so these are the three types of the category. Now one by one we are just approaching towards the define. So here we have the first basic identity of the static friction. The force of friction comes into play between the two bodies where actual motion yet not start and the block does not move. Now the force of friction is called the static friction. Okay, so it does not allow the box to move on a surface. Now the next friction we have the limiting friction or the maximum value of the static friction. So I am just representing in the subscript F as max. Okay. Uh, Maximum value of the static friction, that is called the force of limiting friction. The force of friction comes into play when a body just start or begin to slide over the surface of another body is called the limiting friction. And simply we can assume that the magnitude of the force of limiting friction is greater than and can equal to the F as max. Okay, so it is a one of the limit value as we are just approaching the magnitude of the force applied. So it just very much equivalent to the force of friction and slightly it increases its magnitude. So the force of static friction that comes into play and the body will just start begin to slide. Now the next we have the kinetic friction. The force of friction comes into play when a body in a state of the steady motion over the surface of another body. The friction is called the kinetic friction we have. So these are the basic defined we have. Now as a body is moving steadily on a surface of the another body, so we can make the concept of the acceleration to it. So easily we can say that the acceleration of a body in the state of the kinetic friction, that is force applied minus coefficient of force of kinetic friction is to be divided by m. So this is the kind of the acceleration will be available in a body whenever it's showing the kinetic friction or moving steadily on a surface of the another body. So in all proper discussion we can say that only the friction comes into play whenever we are applying the force of whenever we are applying the force on another body. Okay, and always a friction will act along the contact surface. So it is a type of a contact force we have. Now the two statics we should keep in our mind whenever we are discussing the meaning of the friction. First is that Fs is less than and equal to, could be that Fs max or equal to the force of limiting friction, or Fk is the less and equal to that Fs max value. Okay, so we have to be keep these relation in our mind. Now we will discuss the graph. How can we represent all the frictions by the help of the graph? Now here we have taken the basic representation of the variation of the force of friction with the force applied. So along the OX axis I have taken the force applied, and along the OY axis I have taken the force of friction. So we have discussed the three types of the friction: static friction, that mean force of limiting friction, that is equal to the meaning of the that Fs maximum, Fs max we have. Okay, and then we have discussed the kinetic friction. So as we are just applying the force on a block, so the graph comes from O to A, where the force of applied is equal to the force of friction. So the portion of the graph OA will represent the meaning of the static friction we have. Static friction. Now we are just assuming the situation in which we have force of static friction, that mean for maximum value of the force of the static friction is greater than equal to the force of static friction. So the box just begin to slide. The box just begin to slide. So in this portion we are just getting the graph from A to B, and then after we are just increasing the magnitude of the force of applied greater than compared to the force of S maximum value is so little bit the force of friction having the less magnitude, and the box just moving steadily. Okay, so in this case the force of friction, that is called the kinetic friction. Here we have on the y-axis. Now the parameter O to A we regard the static friction. Okay, now parameter A to B, the maximum value of the static friction will make the concept of the force of limiting friction, that is Fs max we have. Then after it we are just applying the force, so the magnitude of the friction reduces and the body will be in the in a steady motion. So the force of friction will execute, that is called the kinetic friction we have. So this is the all about with the sense of the graph we have. So in this topic we have discussed the meaning of the friction, friction as a contact force, and the types of the frictions we have, as we are just applying the force on a body which is in contact to the surface. Okay.